this is where it comes from. See? This is where ratio comes from. The ratio of this radius to this radius is 1. That is to say, the radii are equal. That's what we mean by the word equal. And that's why the word equal, that's what it means. Equal is not something we decide, is this ineffable relationship that turns out to be excruciatingly important, say, for example, in reductive economics, bottom lines, checkbooks, and whatnot. So now, a couple of other things interesting happened here. These two circles cross, and I haven't said, I've marked their centers, but I haven't marked those 2 points. Those 2 points are very significant. Now, what we in the West do to generate number, what we in the West do to generate number is a process that is called replicating to scale. We are going to replicate this distance to scale. As we've already begun it here. This distance replicates this distance. This distance replicates that distance. So we have a beginning of a process of self-replication to scale. And I will quickly indicate that here. So the replication is progresses. And it is as if the sheet of paper is infinite in extent. And applications here. So this now is how we develop a meaning for this distance between my fingers, this distance, and this. So we simply find names for those. And a name for this distance we'll call 2, and for this one we'll call 3, and this one 4, and this one 5. And we are capturing the notion of counting. Now, it is not possible for anybody to say to anybody else, what is counting? Counting is a most mysterious procedure that we all buy into quite comfortably and find it quite fruitful from toddlers. And what mathematics does is engage, inscribe, capture the process of counting along a line, along what is called the number line. And we are able to speak of the ratio of 2 to 1, or of the ratio of 3 to 1, or the ratio of 3 to 2, because we have these measure lines. And that is the basis of the meaning for rational number, the ratio of countable numbers. And we assume tacitly that these are the counting numbers. The ones that we learn. And these are the numbers in terms of which all of mathematics is constructed in the architectural sense and in the scientific thinking sense. Now, I want to draw. Let's see how I'm going to do that. I need to draw some more circles. And I better draw one down here. Now, I haven't thought this out well, but it doesn't matter, you see. I know where I'm going. You don't know where I'm going. And if you're a mathematician, you will enjoy that. And if you're a non-mathematician, you will get nervous because you think, jeepers, we need to know where we're going. We don't need to know where we're going. Trust me. And the mathematician, I welcome the challenge. I need to put, for my purposes, I need to put 4 more circles here. And there, and there, and here. And all of this, now, for the non-mathematicians, you don't need to worry and get lost about what the heck is going on here. So far, you could do anything that I've done if I'm over your shoulder pointing, draw the circle, center it here, and the circles are all the same size. And I'm going to draw a couple of more lines now. We've got this line, and I drew these 4 extra circles in order to create this point, and that point, and that point, and that point. Because I drew the circles to create points. And these points are forming a pattern. And the pattern is developing more and more complexity. But the reason I drew those 4 points, those 4 circles, is to get these 4 green points, if they can be seen to be green. So that, according to the laws of Euclid, I can draw that line. Because I have these 2 points that allow me to do that, and these 2 points allow me to do that. They are the same line, and I can draw that. Now, I'm drawing these lines in green for a reason that I'll tell you further down the line here in a minute. So I needed these 2 green lines. And one of the reasons that I do the lines in green is for vocabulary, so that I can look at you and say the green line as distinct from the black line. And later on, we can talk about perpendicularity, see, and notice that the green lines are perpendicular to the black line. And you don't know what perpendicular means, but perpendicular means the relationship between, the angle relationship between these lines. And perpendicularity is a very important qualitative relationship of form. See, there's no number about perpendicularity. We can squeeze and say, well, this angle has a size, a quantity that is the same as that angle, that the 2 angles are equal in the special. We can try to squeeze it as if we need to go to quantity to name and know a qualitative property. So I wanted to get those 2 uprights because now there are 2 circles that I'm going to just draw, and this set of circles that I'm going to draw now, you non-mathematician, would never imagine to draw, and neither would I, in '78. I don't know how it is that I came about to learn these recipes. And you probably don't remember how you learned to walk or to tie your shoes. It's the same thing. But there is a set of from the New Age thing. When I say that, once I get out, remember that I drew this line from the 2 points and a string of circles along that line so that I could construct a linear definition of the meaning of 1, 2, 3, 4, 47, 1,082. It goes on forever. An infinite, accountably infinite string of measures by self-replication to the scale of unity. Where I wanted, and then I departed to these green lines, those 4 extra circles in the green lines, because I wanted to do something. Now, what I want to do is to draw some circles that are not the same radius as this unit generating circle, whose radius we are inclined to call 1, so that two of the diameters can be 2 and so on. So I want to draw now some more circles. And I'm pulling these out of the hat in the same way that a kindergarten teacher has to pull out of the hat. How do you spell cat? Because C-A-T becomes the representation of them. And we just have to, so that's the same thing I'm doing now. Is on the cover of the Sacred Geometry book by Robert Lawler is a photograph of the teacher of, what's his name? Leonardo da Vinci. See, Leonardo da Vinci had to have the same thing happen to him that is happening to you. And that is the same thing that Van Dorn was doing in Greenville, South Carolina, last week. Van is simply doing the very same thing. This kid had no idea of geometry or whatever, but Van knows how to engage his affective and how to direct his psychomotor so that his affective gets excited about what he's doing and instructs his intellect to get busy and learn about this recipe. And that's what's going on here. And this is what's been going on in geometry for at least 2,500 years. And the same thing happened with me, and that's how I happened to learn how to put together the recipe, how to know what circle to draw. The geometry teaches you also where to draw the line. What circle to draw and where to draw the line. And what this means completely in terms of psychology, in terms of behavior, in terms of acculturation, with respect to war and the like. So I'm going to draw a couple of green circles. That's about right. You may not think camera may not think it's green. But there's a green circle centered here. And I'm going to draw a green circle centered there. Now, you know what I mean by